The uses of architecture descriptions. Architecture acts as a boundary object. Now that is a term that's coined by the woman Starr. I keep thinking of the name Brenda Starr, but I don't think that was her name, but certainly Starr. She was a social anthropologist and was looking through historical records in some particular area, and she had this I guess epiphany, this whole idea that there were things that people were using as a means to communicate, but everybody didn't agree about the totality of it. And the thing itself became the means of communication. It was an object on the boundary between the different domains. So a boundary object is something that serves as an interface between different communities of interest. And I think in terms of the technical people and the business people, they are two different communities of interest and frequently have a great deal of difficulty talking to each other. Now, unless and until you're going to completely align their vocabularies, which becomes difficult, it's more productive to talk about some common expression between them. Now, the architecture is that common expression of something between them. Everybody can have a look at it and everybody can agree on what's represented there enough to make progress. So there's enough agreement about the features of the boundary object to enable meaningful dialogue. We don't all have to agree about everything. We just need to agree about those things. Each community of interest might interpret different parts of the boundary object differently. Doesn't matter. For example, the business people will have a look at some part of it and think in terms of what it offers them. The technical people will look at it at the same feature and think in terms of what it means for the implementation. So although everybody can agree on what it is, its significance and interpretation might well be different. A system or software architecture is a set of models that enable the stakeholders to understand and discuss what the system will be and will do. Right? That's a very good boundary object. To completely qualify as a boundary object, everybody is supposed to be able to make changes to it, to add things to it for their purposes without necessarily affecting other people. Now, that's probably not going to happen with a software architecture. It's normally people make changes via the agency of the architects themselves. The uses of description, architecture description, they have many uses through a variety of stakeholders. And I've got 3 pages of uses, so I won't go through all of it in detail, but I will say that it's a basis for system design and development activities. It's a development and maintenance documentation, so it spans the developers and the maintainers, the developers and the business owners, several generations of developers. It documents essential aspects of the system, such as the assumptions and the intended use and environment, the principles and constraints to guide future change, the points of flexibility or limitations of the system with respect to future changes, the architecture decisions and their rationales. These things should be conveyed in what's collectively called the architecture documentation. It can be used as input to automated tools for simulation, system generation and analysis. There's increasing number of people are trying to come up with some extension of model-driven architecture, where the architecture itself then goes into a code generator that just generates the system from there, or generates a lot of it. I was at a company that used one of these. Originally it was called Object Tree, and Rational bought Object Tree and it became part of the Rational Rose suite of products. It worked very well, but the developers didn't like it because they rather thought it was just paint by numbers programming and not worthy of their skills and expertise. They'd rather code in C. However, the company loved it because the error rate was about a half what it would have been with C code. And we know that because we originally were coding in C and C++, and object tree was used, and we had a subsequent view of just exactly how many errors came out of it. So it was good, but programmers hated it. To specify a group of systems sharing common features such as architectural styles, to communicate among parties, to communicate the characteristics and features, to aid in legacy planning, to guide the operational infrastructure, support and configuration. There are a lot of things that the architecture documentation supports. Now, a lot of this is because many of the major characteristics of a system are decided and determined by or with the architecture, and certainly the documented architecture can convey a lot of this information. So it has a wide scope of applicability. Who reads the documentation? Which part of the documentation? Why do they read it? Okay, we have a list. In fact, we have 2 pages of lists. Stakeholders, the architect and the requirements engineers who represent the customer. They negotiate, make trade-offs among the competing requirements. Now, those get represented in the architecture. Architect and designers are the constituent parts. Obviously, the architects themselves read the architecture and all parts of the architecture. The implementers read the architecture so they can implement it. Testers and integrators read the architecture to find out what's going on. Maintainers, designers of other systems with which this system has to interoperate. More of who reads it? Quality attribute specialists. So they will want to know whether this system delivers what it's supposed to. Managers, to create development teams corresponding to work assignments. There is a law, Conway's law, where the architecture of a system tends to reflect the communication patterns within the organization. Now, it's loosely interpreted as the architecture of a system will reflect the organization structure. Well, the organization structure tends to determine the communication patterns, but more to the point, the original law was, original observation was that the architecture of the system reflected the communities and their communication patterns between them. It just means that if you have 3 groups of people, you're probably going to have 3 parts of the architecture. I think one observation was there was a group going to make a compiler, and they were 3 separate groups. For some reason, I've forgotten whether it was they were divided by divisions or divided by geography. But the compiler that was finished was a 3-pass compiler. No surprises there. Product line managers, they want to determine a potential new member of the product family, particularly if you're developing a product line architecture, but product line managers have some interest in it all. And the quality assurance team has an interest in the documentation. So it's important to a number of people. And it's something with which, over which everybody can communicate. It's kind of like a cup of tea or something like that. It's not the tea that matters, it's the communication that goes on over the cup of tea. An architecture is usually the first thing that enables all of the stakeholders to examine the system and how it will affect them. Not perfectly, but it's much more difficult to do that with, for example, requirements. And it's probably the earliest stage at which you can get communication both ways. You can get it down to the developers and testers, and you can get it back up to the business owners over the architecture. So an architecture serves many purposes. So these are the reasons why you need to document the architecture.